this class. Now I am going to explain you an ellipse. First let us see the definition of an ellipse. If a locus point which moves on the plane such a way that the sum of the distances from two fixed point to the locus point is constant or same, then such locus represents an ellipse. See, here one locus point is moving like this on the plane. How this locus point is moving? See, the sum of the distances from two fixed points on this plane is always constant. See, here it is a locus point P, and S and S dash are two fixed points on the plane. Measure this distance and measure this distance and add both of them, SP plus S dash P. So which is always equal to same or constant. You can take this P anywhere on this locus, either here or here or here. Measure the distance from P to these two fixed points and add both of them. So this result will be always same or constant. So this constant value must be smaller than the distance between these two fixed points. Okay, then this locus represents an ellipse. See, you know the eccentricity definition. So for this ellipse, eccentricity value is always lying between 0 to 1. And let us go to derive the standard form of an ellipse. And before that, we need to discuss some terminologies related to this ellipse. Let us see them. See, consider the Cartesian system. X dash, y dash. See, consider this locus whose center is at origin, and consider the two fixed points over here on x-axis. One is S1, S, and other one is S dash. And for this ellipse we get to two directrix. One is this side and one more is this side. So here observe that on this ellipse x-axis length is more, hence x-axis is major axis for this ellipse, and y-axis length on this ellipse is less, hence y-axis will be the minor axis for this ellipse. So let us consider these points. This is A and this one is A dash, and here let us take this is B, B dash. Consider the A coordinates as A comma 0 and A dash coordinates minus A comma 0, and B coordinates 0 comma B, B dash coordinates 0 comma minus B. Okay, right. So hereafter, okay, take any locus point on this ellipse as P. Now connect SP and here PM. You know, SP by PM is equal to E. Okay, so but this P you can take anywhere on this ellipse, no? So that, okay, I am going to replace this P by A, because in place of P you can take A also, because A is also one of the point on the locus. So SA by the distance from that locus point to the directrix in this figure, let it be Z, AZ, and this is Z dash. So SA by AZ, which is equal to E. Now SA plus E of AZ So which is equal to equation 1. Similarly, I am going to consider that locus point here, A dash. If you take A dash as locus point, then eccentricity definition will become SA dash by A dash Z. So I am going to define an eccentricity with respect to this focus and with respect to this point, A dash. So SA dash by the distance from this locus point to directrix. This directrix only I am considering. So that here what do you get? SA dash by A dash Z, which is equal to E. Now bring it to the right side. So that what do you get here? SA dash, which is equal to E of A dash Z. Now let it be equation 2. Okay. Now add both of them, and before adding, see students, SA can be written as, so this is CA minus CS, am I right? SA can be written as CA minus CS. CA minus CS, now which is equal to E of AZ. AZ, in this figure AZ can be written as, so CZ minus CA. What I am writing in place of AZ? See here, AZ can be written as CZ minus CA. CZ minus CA. Okay, go to this one. S A dash, which can be written as CS plus CA dash. CS plus CA dash. CA dash plus CS, which is equal to E of A dash Z. A dash Z can be written as CA dash and CZ. CA dash plus CZ. So now I am adding these two. So if you add these two, what we are getting? These two are get cancelled. So in this figure, CA length is equal to CA dash. How much CA? Small a. Even CA dash length also small a. Okay, both are distances. Don't take it as minus a. Okay, length no. So it should be expressed as positive. Now add both of them. Both quantities are equal no. So here CA is equal to CA dash. So that on adding these two, you will get 2a, which is equal to E of. If you add these two, so observe Amma here, CA and CA dash both are same no. One is having minus sign, one is having plus sign. So both are get cancelled. So that here you will get CZ plus CZ, 2CZ. So 2 get cancelled. Now CZ is equal to A by E. CZ means the distance from here to here is how much? A by E. So that the coordinates of Z are A by E comma 0. Coordinates of Z are A by E comma 0, because so this directrix is moving how much far away from the center? A by E units. So it is a vertical line. On the vertical line, x coordinate of every point is same. Hence the equation of this directrix is x equal to A by E. Okay. Similarly, this is one more directrix no. So whose equation will be x equal to minus A by E. So both are moving equidistant from the center of an ellipse. So one of the directrix equation is x equal to A by E, and one more is x equal to minus A by E. Okay, right. Next two. So here on adding these two, you got a directrix equation. Here what are the coordinates of Z? A by E comma 0, because Z is there on the x-axis, so that whose y coordinate will become 0. Here Z dash coordinates minus A by E comma 0. Right. On adding these two, you got the directrix equation. Now subtract both of them. Subtract. Here CS. Here this is CS. CA dash CA. Now subtract both of them. On subtracting, what do you get? Here CA minus CS minus CA dash plus CS. So which is equal to RHS. So CZ minus CA. So while subtracting, we have to change the signs here, you know. So here minus CA dash minus CZ you will get. Now simplify this. So when you open this brackets here, signs will change. CA minus CS minus CA dash minus CS. So which is equal to E of CZ minus CA minus CA dash minus CZ. So in this figure both are equal. Hence both will be get cancelled. Here minus 2 into CS. And here what can we cancel? These two are cancelled. So what is left? Minus here both are equal quantities, no? So here CA CA. Okay. So minus 2E CA. Minus cancel, 2 cancel. So what is left? CS is equal to CA. In this figure CA length is how much? Small a units, no? Right, in place of CA as small a. Then CS will become, CS means this distance. So here which is equal to E of E into CA. CA means how much E is here? Small a. So CS length is AE you got. So here we got the CS length. That is nothing but the coordinates of S are AE comma 0. Okay na students? So we defined the eccentricity. Okay. So in two ways we have defined that eccentricity. One is SA by A dash which is equal to E, and one more is SA dash by A dash Z is equal to E. Two equations were generated and both we have added, so that we got the directrix equation, that is x equal to A by E, and both we have subtracted. On subtracting we got the coordinates of an eccentricity. Okay, so one focus coordinate, on adding we got the equation of the eccentricity, directrix equation, and while subtracting those two, so we have been generated coordinates of focus AE comma 0, and one focus coordinates AE comma 0 and other focus coordinates can be minus AE comma 0. Okay, right. Right, in that figure, observe carefully. See here. X dash, Y dash. See here. This is an ellipse. Here for this ellipse, okay, here it has two foci whose coordinates AE comma 0 minus AE comma 0, and here directrix equation x equal to A by E, and one more x equal to minus A by E. Okay, as you know, this is A dash. Now take P here. Okay, now SP and S dash P, add both of them. What do you get? Tell me. SP plus S dash P length is how much? How do you measure SP plus S dash P? Students, tell me. Let us consider this P coordinates as x comma y or x1 comma y1. So SP plus S dash P. I want. How do you measure it? So if you want SP, okay, so you know SP by PM, okay, so is equal to SP by, this is M, so you know this relation SP by PM is equal to E. Now SP is equal to E of PM, E of PM. So now PM length, how do you measure? Drop a perpendicular from P to X axis, so that this coordinate will be x1 comma 0. Now in this figure, this PM length is equal to this length. How much will it be means? So from here to here it is A by E, from which if you subtract this x1, you will get this length. Now which is equal to E of, here use the mod symbol. So from here to here, how much is this? A by E. Now A by E minus x1. Similarly, I want S dash P. Even S dash P, how do you write? So S dash P by S dash P by, so from here to here, drop a perpendicular from P to this directrix. Okay, S dash P by P, let it be M dash. So P M dash is also known as an eccentricity. So simplify this. If you simplify this, what do you get? S dash P is equal to E of P M dash. Now S dash P is equal to P M dash value will be how much in this figure? From here to here it is x1, and from here to here it is A by E. So I want total length, means what I have to do? I should add this length and this length. This is x1 and this is A by E. So x1 plus A by E. x1 plus A by E. Okay. Now, so I want this SP plus S dash P. So how much I am going to get? So here, do that simplification. SP plus S dash P. SP value here you got. So when you send E inside, E cancel. So you get A minus EX1. Plus similarly, here S dash P. So here how much do you get? And before this here we have E. So multiply E with these two terms, so that here you will get EX1 plus E cancel, A you will get. So both are cancelled. A plus A, 2A. Okay students, SP plus S dash P, which is equal to how much? 2A. 2A means length of major axis. See students, from here to here, A, here to here, A. So this total length will be called 2A now, that is AA dash, that will be called length of the major axis for this ellipse. Okay, so the sum of these two distances is equal to how much? 2A. Okay, the locus, okay, which satisfies this relation is known as an ellipse. You can define the ellipse definition like this. SP, the locus which satisfies SP plus S dash P is equal to 2A is known as an ellipse. Now I am going to derive standard form of an ellipse equation. So for that I want to use this previous relation, SP plus S dash P is equal to 2A. So students, you know this diagram. Okay, S coordinates, you got AE comma 0 and S dash minus AE comma 0. Now this is locus point. In the previous diagram, so you got SP and S dash P is equal to how much have you got? SP plus S dash P, which is equal to 2A. Now the measure the distance from S to P. You know this ellipse see this locus point, you can take x1 comma y1. After getting the equation, replace x1 y1 by x comma y. You know how you have to do the locus problems. So right. Okay, SP. The distance from S to P, how much? x1 minus AE whole square, and okay, difference of x coordinates, difference of y coordinates, y1 minus 0 whole square. So which is equal plus s dash p. How much is this? So x1 plus AE whole square plus y1 square, which is equal to 2a. Now transfer this one to the right side and go for squaring on both sides. x1 minus AE whole square plus y1 square. Shift this one to the right side. 2a minus the square root of x1 plus AE whole square plus y1 square. Now hereafter go for squaring on both sides. If you take squaring on both sides, here x1 minus AE whole square plus y1 square. So which is equal to, here it is looking like a plus a minus b whole square. Am I right? What I am doing, I am taking square on both sides for this. So if you take square this, so here square root and square get cancelled, this is left. And here it is looking like a minus b whole square. You know whose expansion? A square plus b square minus 2ab. Minus 2ab means this is a, this is b. Minus 4a of root of this one will come. x1 plus ae whole square plus y1 square. Right, simplify this. If you simplify, what do you get here? Okay, so here expand it. x1 square plus a square e square minus 2ae x1 plus y1 square, which is equal to 4a square plus x1 square plus a square e square plus 2ae x1 plus y1 square minus 4a of square root of x1 plus ae whole square plus y1 square. Now students, see here, both can be cancelled because both are equal quantities which are lying on either side of the equal symbol. And a square e square also get cancelled. Now y square cancelled. Okay, transfer this one to the left side so that you will get 4ae x1, which is equal to minus 4a square root of x1 plus ae whole square plus y1 square. Now minus minus cancel, 4a also get cancelled. Now again square on both sides for the leftover quantities. So here you will get e square x1 square, so which is equal to, there x1 plus ae whole square plus y1 square you will get. Am I right, students? Here it is having square root, so that okay, square root will be going to eliminated by taking square on both sides. Now simplify this. E square x1 square, now which is equal to x1 square a square e square plus 2ae x1 plus y1 square. The next step, what I have to do? Students, tell me. Bring it to the left side. So if you take this x1, okay, otherwise shift this one to the right side. What do we get? which is equal to, when you take this one left side, so 1 minus e square x1 square, and here y1 square. So from these two, what do we take common? From these two, what do we take common? AE common. AE. When you take AE common here, students, here we did one mistake. Here, okay, when you bring this one left side, here minus 4AE x1 we get, and here one 4A square is there. Here we have forgot to write this one. See here, again you do from here onwards. See here, when you bring this one left side, so minus 4A EX1, and here it is minus 4A square. When you bring left side, minus 4A square will come, and here it is minus 4A square root of x1 plus AE whole square plus y1 square. So from these two, what do we take common? Minus 4A you can take common. So when you take minus 4A common, so here it is minus 4A. So here EX1, here okay, one A will be left. So here it is minus 4A. Now square root of x1 plus AE whole square plus y1 square. Minus 4A cancel. So again go for square on both sides. When you take here square on both sides, e square x1 square plus a square plus 2ae x1 you will get. Here when you take square on both sides, the square root will be going to eliminate now. After that this expression will be left and simplify that. So here x1 square plus a square e square plus 2ae x1 plus y1 square. Again this 2ae x1 and this 2ae x1 can be cancelled because both are equal quantities lying on either side of the equal symbol, hence we can cancel it. Right, now simplify left over. Okay, here this a square no, only here a square is there. So transfer this leftover terms to the right side, so that what do you get here? So when you transfer this one right side, here x1 square, here e square x1 square is there. When it goes to the right side, so 1 minus e square x1 square will come, and here okay, when you take here a square e square, bring it to the left side. A square e square, when you take this term to the left side, so here already one a square is there, so 1 minus e square will come left side. So this one we shifted to the right side, so that you got this one, and here one y1 square is there. So hereafter both sides now I am going to divide with this one. So here a square of 1 minus e square, a square of 1 minus e square. Now left side, which becomes 1, and here these two will be get cancelled. X1 square by a square plus y1 square by a square of 1 minus e square. Okay. Now as I said to you, for an ellipse e value is always lying between 0 to 1, hence this quantity is always positive. Am I right? So 0 to 1, when you raise whose power, whose value is smaller than 1, 1 minus smaller than 1, this is positive, and a square is positive, hence this expression is always positive. So let us take that positive quantity as b square. Now b square is equal to a square of 1 minus e square. Okay, observe that here. So your a square value is more than b square. When you take square root on both sides, you will get a is more than b. Okay, if you consider this one as b square, then it will become x square by a square plus y square by b square, which is equal to 1. So this is known as equation of an ellipse in the standard form. Otherwise, you can call it as standard form of an ellipse equation. X square by a square plus y square by b square equal to 1. Okay, now once again let us draw the figure for it. X dash, y dash. Now see, this is an ellipse whose equation is x square by a square plus y square by b square equal to 1. And for this is the center whose coordinates are 0, 0. And whose foci coordinates, tell me foci coordinates, AE, 0 and S dash coordinates minus AE, 0. And whose directrix equations, so x equal to A by E, and one more directrix equation, x equal to minus A by E. Okay, and yeah, these are called vertices whose coordinates are A, 0 and one more is minus A, 0. And here this one 0, b and b dash 0, minus b. Okay, so for this ellipse we got b square is equal to a square 1 minus e square. Okay, this relation we got while we were deriving that ellipse equation. Okay, now simplify this. So b square, so which is equal to a square e square. Now bring it to the left side, so that what do you get? A square e square, which is equal to a square minus b square. Now transfer this on right side. E square is equal to a square minus b square by a square. When you say shift the square root right side, square root of a square minus b square by a square. Okay, so you can use this relation to find eccentricity of this ellipse. E is equal to root a square minus b square by a square. See here, center of this ellipse is origin 0, 0. Foci coordinates AE, 0 minus AE, 0. Okay, right. Next, these are vertices A, 0 minus A, 0. And x equal to a by e and x equal to minus a by e are the equations of directrix of this ellipse. Now let us go to find the equation of latus rectum and the length of latus rectum for this ellipse. See, x dash, y dash. What I am going to find? Length of latus rectum and equation of latus rectum. What is latus rectum? You know, you have learnt in the parabola. So same definition. Okay, you can define for this ellipse also. Okay, how did you define this latus rectum while you were learning the parabola? A double ordinate which passes through the focus of a parabola is known as a latus rectum. No, here also the double ordinate which passes through the focus is known as latus rectum. So you know, ellipse has two foci. Hence here also you will get two lattice rectums. So one is LL dash. Here you can take one more like EMM dash, or you can take it as LL dash, NN dash. Both lengths will be equal. Okay, how much is that length of lattice rectum? Tell me. So here x square by a square plus y square by b square is equal to 1. Right. Now here it is passing through a comma 0. Now this is vertical line. On the vertical line, as you know, so x coordinate of every point is same. So here L x coordinate is AE, L dash x coordinate is AE. But y coordinate here you don't know. How do you get y coordinate? This AE you have to substitute in the place of x in the equation. So that here what do you get? A square E square by A square plus y square B square is equal to 1. A square cancel. So now what do you get here? E square is left. So for this ellipse, E square value is how much? A square minus B square by B square you will get. Now in place of E square write that. So that what do you get here? A square by B square minus B square cancel 1. So plus y square by b square, which is equal to 1. Okay. Now simplify this. On simplifying this, what we are going to get? Okay, cross multiply here. A square minus b square plus y square by b square. Now which is equal to 1. Okay, now simplify here. What do we get? So here a square minus b square plus y square. So now which is equal to b square. So when it goes to the right side, so now y square is equal to 2b square minus a square we are getting. Okay, I think somewhere we are making mistake. Where it is? Here we made mistake. Here we got a square, not b square. Okay, so this relation we got now. Just now we have seen b square is equal to a square of 1 minus e square. Now simplify this. So b square a square minus a square e square. So a square e square, which is equal to a square minus b square. So that here e square is equal to a square minus b square by a square. Okay. So here this is e square. A square is equal to a square minus b square by a square. So now see here. Here we have substituted now e square is equal to how much? E square. E square is nothing but this much. Replace this e square by this. So that what do you get here? A square minus b square by a square plus y square by b square, which is equal to 1. Now simplify this. So here, what is the LCM? Here a square, now divide this a square with these two, so that you will get 1 b square by a square plus y square by b square, which is equal to 1. So this one get cancelled. Shift this one to the right side, so that here you will get y square by b square, which is equal to b square by a square. Okay, right. Now transfer this b square to the right side, so that here you will get y square is equal to b power 4 by a square. Now transfer this square to the right side, so that you will get plus or minus b square by a you will get. Now you got two values for y, so one you have to write here b square by a, and one more here you have to write minus b square by a. Now add both of see, you got end points of this lattice rectum, ae comma b square by a, ae comma minus b square by a. So if you want to write the end points of this lattice rectum, what do you get here? Minus ae comma same b square by a you will get, and here n dash coordinates minus ae comma b minus b square by a you will get, because it is there in the third quadrant. So both will get minus sign. Now find this length LL dash. So here the both are equal now. So this distance both are equal. This distance is b square by a. Even this one will be also b square by a. So that you will get 2b square by a units is the length of this lattice rectum, and whose equation, it is a vertical line, x coordinate is same. Hence equation of this lattice rectum is x equal to ae, and this lattice rectum is x equal to minus ae. Okay na students? So anyhow you know this x axis is the major axis whose equation is y equal to 0, and here y axis is the minor axis whose equation is x equal to 0. Okay, now observe this equation students. X square by a square plus y square by b square is equal to 1. Now suppose if you make y as subject, what do you get? Y square by b square, which is equal to 1 minus x square by a square. So if you take b square right side, y square is equal to b square by a square, 1 minus a square minus x square you will get. When you transfer square that side, so y equal to plus or minus b by a root of a square minus x square you will get. Suppose if y is a real number, okay, so this value will be a square minus x square greater than or equal to 0. Am I right? When do you get a real value for y? So whenever this is either 0 or positive. Okay, so even this can be also written as x square minus a square less than or equal to 0. Even so, what do you write this one? So x plus a into x minus a less than or equal to 0. What is the solution set for this? Your x value must be lying between these two, x equal to a and x equal to minus a. Okay, that is, so minus a less than or x less than or a. So x must be minus a comma a. Similarly, if you want to make x as subject, so what do you get? X square by a square, which is equal to 1 minus y square by b square. Now x square, when you take a square right side, a square by b square, so b square minus y square. When you take square that side, plus or minus a by b, root b square minus y square you will get. Suppose if you would like to get x value is real and this must be real, b square minus y square should be greater than or equal to 0. If you simplify same like that, so your y value will be, okay, minus b2 plus b. Minus b2 plus b. So now observe this figure again. So you know x equal to minus a means which passes through this vertex, x equal to minus a, and x equal to plus a means which passes through this vertex, because we have taken these coordinates as a comma 0, this coordinates as minus a comma 0. And similarly this is b dash now in the standard form. So this is y equal to, here if you take it is a comma 0, this is minus a comma 0, and this is 0 comma b and minus 0 comma minus b. So whose equation is y equal to b, and whose equation is y equal to minus b. Okay, so obviously this ellipse, okay, it is bounded by these four lines, 2 are horizontal, 2 are vertical. Okay, so x equal to a, x equal to minus a, y equal to b, y equal to minus b, and this ellipse is symmetrical about x axis as well as y axis. This ellipse is symmetric with x axis as well as symmetric with y axis. So this is about standard form of an ellipse. So what we have seen here, we have learnt the definition of an ellipse, and also so we derived the coordinates of foci of this ellipse, and we derived directrix equation, and also we derived standard form of an ellipse and whose properties we have seen. And every time this major axis need not be x axis, need not be y axis. Sometimes major axis may be y axis. If the major axis is y axis, how that ellipse will be, let us see. X dash, y dash. Now the major axis is y axis, then your ellipse will be along with y axis like this. Same equation we will get, but here b value will be more than a. So your b value is more than a, that should be positive. So whose equation is this? And no changes will come in the center, 0 comma 0. Here this is small 0 comma b, and b dash 0 comma minus b. And here it is a comma 0 and a dash, so minus a comma 0. And here you will get one focus, here you will get one more focus, SES dash, whose coordinates 0 comma BE and 0 comma minus BE. And here you will get one directrix, and here you will get one directrix. So whose equations will be, so y equal to b by e you will get here, y equal to minus b by e, and this is lattice rectum, and this is one more lattice rectum. Okay, so you know lattice rectum, horizontal line equation, y equal to k, here k value is be, length, okay, equation of lattice rectum is y equal to be and y equal to minus be. And when you know y equal to minus be, so substitute y equal to minus be here and go for simplification. So you will get that length of lattice rectum here, okay, 2a square by b you will get. For the previous one you got 2b square by a, no, but for this you will get 2a square by b units. Okay, and eccentricity value for this, so square root of students, so here we will get b square minus a square by b square. For the, if the major axis is y axis, whose length is from here to here 2a, minor axis is x axis, whose length is 2a. Major axis length 2b, minor axis length 2a, and eccentricity root b square minus a square by b square. So here we will get a square is equal to b square of 1 minus e square. So for this ellipse, a square is equal to b square of 1 minus e square. Now eccentricity is root b square minus a square by b square. Okay. So directrix equation you got, foci coordinates you got, lattice rectangle length you got, and equation of lattice rectangle is so here y equal to b, here y equal to minus b. Okay, right. I hope you have understood if the major axis is y axis. Okay, so now if the major axis is parallel to x axis, then how do you get that ellipse? See here, just you need to shift the origin from here to here, h comma k, without changing the direction of x axis and y axis. So x dash, y dash. So this is the origin. Now what I am doing? I am transforming this origin from here to here, h comma k. Then you will get ellipse like this. For this ellipse, so this is major axis and this is minor axis. Both are intersecting at this vertex h comma k. So what we have done, we shifted origin from here to this point, then the ellipse equation, you get ellipse like this on shifting the origin from 0, 0 to h comma k. So then the equation of this ellipse will be, so you know, if the major axis is x axis, minor axis is y axis, and a is greater than b, you got ellipse equation x square by a square plus y square by b square equal to 1, no? And for this ellipse you will get x minus h whole square by a square plus y minus k whole square by b square, which is equal to 1. You remember like a standard result, just replace x y by x minus h, y minus k. Okay, actually here with respect to new axis, whose equation is capital X square by small a square, capital Y square by small b square equal to 1. With respect to new axis, if you treat this is new x axis, new y axis, then the equation of this ellipse will be capital X square by a square, capital Y square by b square. But you know, in the transformation of axis, the relation between the old coordinates and new coordinates, small x equal to capital X plus h, small y equal to capital Y plus k. Now capital X equal to x minus h, capital Y equal to y minus k. In this replace x, y, capital X, capital Y by these two, so that you will get this equation. Okay. Now write center, foci coordinates, directrix equations and all for this. Okay. Whose equation we have written here, and here you will get focus. How do you get? For the previous one you got AE comma 0. Just you need to add here H, because from here to here H, from here to here AE. So that H plus AE comma, so K you will get. H plus AE comma K is the coordinate of this foci. And what about this? S dash, from here to here H, from which you have to subtract this AE. So that you will get H minus AE comma K. Focus, okay, foci coordinates you got. Next, here you will get a directrix, and here you will get one more directrix. So can you expect the equation of this directrix? So for the previous one, x equal to a by e, no, just you have to add from here to here h, from here to here a by e. So x equal to h plus a by e. And what about this directrix from here to here h, from which you have to subtract this a by e. So that x equal to h minus a by e. Easy to remember. Just previously you got x equal to a by e, x equal to minus a by e, just you need to add here hh, that's it. So that you will get whose directrix equations. No changes will come in the length of the lattice rectum. If you want to do, you can identify the extremes of this lattice rectum. How to identify extremes, okay. Just here vertical line, x coordinate is same, h plus x ae. Substitute this value in the ellipse equation so that you will get y value. After getting y values, find the length. Okay, you will get, so same. So if the major axis is x axis, you got like this, 2b square by a. Similarly, for this one also you will get length of the lattice rectum is 2b square by a. And equation of lattice rectum, x equal to h plus ae, and here x equal to h minus ae. Okay, students. Right. Okay. So this is about an ellipse whose major axis is parallel to x axis. If a major axis is parallel to y axis, then how do we get whose standard form? Let us see. Right. Okay. So for the previous one, equation of major axis is how much? Equation of major axis. This is the major axis now. So that major axis was parallel to x axis. If a line is parallel to x axis, means horizontal, on which y coordinate of every point is same, so that equation of major axis for the previous ellipse is y equal to k, and equation of minor axis is x equal to h you will get, because both are passes through h comma k, vertex was h comma k, hence major axis equation is y equal to k, minor axis equation is x equal to h. Now let us see, if an equation, the major axis is parallel to y axis, x dash, y dash, and now see axis of an ellipse along with this. So this is a minor axis. So center is h comma k. Then whose standard form is h minus x h whole square by a square, and y minus k whole square by b square, which is equal to 1. Now write all of them. Focus coordinates h comma k plus b, and here s dash h comma k minus b, and here you will get one directrix. So whose equation is y equal to k plus b by e you will get, and here you will get one more directrix whose equation is y equal to k minus b by e. Now major axis equation is x equal to h, minor axis equation is y equal to k. Okay, you can able to write this vertices coordinates, these coordinates. Am I right? Write by yourself. So from here to here. So okay, can you able to write this vertices coordinates? So this length is b, and from here to here k. So here h comma k plus b you will get, and this coordinates h comma k minus b. From here to here h, from here to here it is a. So now okay, h plus a comma k, and this is h minus a comma k. These are vertices, okay, of an ellipse, and length of the lattice rectum. So LL dash is 2a square by b you will get, and for this eccentricity root of b square by a square by a square we will get, sorry, b square. Okay, so these are various forms of an ellipse. So in the next class, now I would like to discuss with you the remaining conceptual points related to this ellipse. Thank you.